All right, let's look at our next recursive problem. We're gonna solve an n choose k recursively. So combinatorial mathematicians count things, and one common thing to count is how many sets can be made from a group of items. So imagine we're running a top 40 radio station. So we only play 40 songs. We play the same 40 songs over and over again. And another thing this station does is they always play 10 songs in a row before there's a commercial. Okay. So the question a combinatorist would ask is how many different groups of 10 songs can be made from the 40 that are available? We call this type of problem n choose k, where n is the number of available items and k is the group size. Okay, so you may have seen these in some math class. Basically, the notation looks something like this: n choose k. So let's go through a couple of these. Let's look at 3 choose 2. So what this means is there's 3 items. How many sets of 2 can be made? Okay, so let's start with let's just pick 3 values. Okay, so here's a set with 3 items in it. The question is, how many groups of 2 can we make? Okay, well, we can see that 1, 2, that's one set. 1, 3 is another. And 2, 3 is another. So order is ignored. In other words, 2, 1 is not any different from 1, 2. So we only count that. We only count that once. So the answer: how many sets of 2 can be made from a group of 3? Okay, 3 choose 2. The answer here is there's 1, 2. So there's 3. 3 choose 2 is 3. Okay, let's do another one. Let's do 4 choose 3. So we have 4 items, and we want to know how many groups of 3 can be made. So we have 1, 2, 3. 1, 2, 4. We have 1, 3, 4. And we have 2, 3, 4. Okay, so I believe those are all the unique sets that can be made, sets of 3, from a group of 4. So there's 1, 2, 3, 4. 4 choose 3 is 4. Let's do one more, slightly bigger one. Let's do 5 choose 2. So again, there are 5 items. How many groups of 2 can we make? Okay, so let's call these our original 5 items. So let's see, we have 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5. So let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 choose 10. How many sets of 2 can be made from a group of 5? Okay, the answer is 10. Okay, so you can see this is kind of painful to do by hand. There is a way to calculate n choose k. Okay. You could say n factorial divided by k factorial times n minus k factorial. Okay, but if you weren't aware of this calculation, or you didn't have a math book handy, or you didn't want to go Google it, you might want a program to do this. And we're going to write a program that calculates 40 choose 10 using recursion. Okay, so let's see. Let's think about this here. So there are 40 items to choose from. And to do this by hand would be impossible. It would just take too long. Okay, so here are 40 songs. Let's pick one of these items at random, maybe the value 3. Okay. Now, in the resulting sets, the groups of 10, some of them will have a 3 in them, and some will not. Okay, so let's look at the sets with a 3, and then later on we'll look at the sets without a 3. Okay, all the sets with a 3 in them, they're going to look something like this. Right, remember, there's going to be 10 items in each set. Right, each one of these has the 3 in there. Okay, so there's going to be a lot of them, but each one of these sets does have a 3 in it. Okay, now let's look at the sets that don't have a 3 in it. Right, so here's one. There are 10 items in this set, and a 3 is not one of them. Okay, and on and on. There's going to be a lot of these sets as well. And you'll notice none of them has a 3 in there. Okay, so if we think about it, hopefully you can convince yourself that the total number of sets is going to be equal to the sets with 3 plus the sets without the 3. So if we count how many are here and add them to how many sets are here, that's the total number of sets in 40 choose 10. Okay, so now we have to think, well, how many sets are there with 3? Right, so how many are in here, this group? Well, since one of the 10 items has already been chosen, the 3, you have 9 to pick from out of the remaining 39. Okay, so sets with 3. Okay, we can't choose the 3 anymore. It's already chosen. And since we know the 3 is already going to be in that group, we only have 9 more to choose from. So that's really 39 choose 9. Okay, if we look at the sets without a 3, okay, since the 3 is not available to pick from, you only have 39 numbers to choose from. Right. So we cannot pick the 3. We have to take that out of the group of 40. But we still want 10 songs in all the sets without 3 will have 10 songs, just none of them will hold the value 3. Okay, so the total 40 choose 10 is equal to basically the sets with 3. 39 choose 9 plus the sets without the 3. 39 choose 10. Okay, and that's going to give us our n choose k. So basically what we've done is we've framed the problem in terms of a smaller version of itself. Okay. Another way I could write this is n choose k is equal to n minus 1 k minus 1 plus n minus 1 k. Okay. But of course we need to identify a base case. Okay, so let's think about this n choose k problem. When n is exactly equal to k, okay, there's really only one way to choose. So if there are 10 songs to choose from and you must select 10 songs, well, there's only one set, right? So if we had 10 choose 10, there really is only one way to do that. So you have 10 songs, you have to pick 10 of them, there's only one. So when n is equal to k, okay, we're going to return the value 1. When k is equal to 1, there are n ways to choose. Okay, so if there are 10 songs to choose from, and you must select sets of 1, they're going to be exactly 10 sets of songs. Okay, so let's say we had 10 songs and we wanted to group them in sets of 1. Well, how many groups of 1 are there can be made out of the 10 songs? Well, there's exactly n, or 10. Okay, so when k is equal to 1, we're going to return n. Okay. Now both of these are going to be our base cases, because they don't really depend on smaller versions of themselves. The general case is going to look like this. We're going to say, well, just like we had here, nk is going to be, n choose k will be the sum of n minus 1 k minus 1 plus choose n minus 1 k. Okay, so let's look at some code here. Okay, we'll see this is a nice, simple, small function called n choose k. So it takes an n, takes a k. We're going to go check our two base cases. So when n is equal to k, we said we were going to return 1. And if k is equal to 1, we're going to return n. The general case is we're going to say, we're going to recursively call n choose k. We're going to pass in n minus 1, k minus 1. That's like the sets with 3. And then the sets without 3, we said was the result of calling n choose k with n minus 1 k. Okay, so up here I'm going to call n choose k. I'm going to pass in 40 and 10. And we'll see that did take a little bit of time. It took a few seconds. And that makes sense because this is a really big number. So if we had 40 songs and we had to choose groups of 10, there are 847,660,528 groups of 10 songs that can be made from the top 40. Okay. So again, if you didn't have the closed form equation I gave you earlier from a math book, you'll see that this is not totally impossible for an average non-mathematician to come up with. And certainly to code it didn't take that much. The trick, I guess, was just realizing the relationships between n choose k is really just solving a smaller version of itself, doing a little bit of arithmetic with two smaller versions of itself. And that's kind of a classic recursive problem.